Good day, everyone. Today we are talking about section 10.1, Simplify Radical Expressions. Our learning target for today, I can simplify radical expressions with numbers and or variables. So to start, we are going to complete this chart. So for example, here we're given 1. What is 1 squared? Well, 1 squared is 1. Next number, 2 squared is 4, and so on and so forth. So please pause the video and complete this chart. Alright, so now that you've completed this chart, these are what are called the perfect squares. And so what happens is we use these with breaking down radicals. So our product property of radicals says that the square root of AB equals the square root of A times the root of B, where A is a perfect square. Which are these numbers that we just completed. Those are the perfect squares. They're also, when you're sitting in my classroom, those white numbers on the wall. They're also, if you have that times table sheet, those italic underlined numbers, those are the perfect squares as well. And so we use these to break down, or what we call simplify radicals. So simplify the square root of 32. So what perfect square, so I'm looking here at this row of numbers, what perfect square goes into 32? And some of you are going to recognize that 32 is the same as the square root of 16 times the square root of 2. The square root of 16 would be 4. The square root of 2 is not a perfect square, so 2 doesn't go down any further, so it stays, which means our answer would be 4 root 2. Now, one thing to note, you could have, if you said that, oh, I recognize the square root of 32 is the square root of 4 times the square root of 8, because 4 is a perfect square that goes into 32 as well, which is fine. You'd say the square root of 4 is 2, but the thing is, the square root of 8, I always have to ask myself, does the radical reduce further? In this case, the answer is yes. The square root of 8 is the square root of 4 times the square root of 2. Again, where your first number that you're picking is a perfect square. So that means the square root of 4 becomes 2, square root of 2 stops. These outside numbers are getting multiplied because realistically, this is all multiplication here. We just don't write it. It's that implied multiplication. So again, 2 times 2 would be 4. Root 2 doesn't go any further, so you get 4 root 2. So as we can see here on top, if we can find the largest perfect square first, it's shorter. But if we can't, we can still get there. It just takes a couple more steps. So I'm going to walk you through one more here. Root 40. What perfect square goes into 40? And that would be 4. And so 4 times 10 would be 40. The square root of 4 would be 2. The square root of 10 does not break down. Again, I'm looking at what perfect square would go into 10. My options are 9 or 4, in which neither one of those divide evenly, so we do not break it down any further. So that means our final answer is 2 root 10. I would like you to pause the video and try each of the next two on your own. Alright, so root 48, again, you could have recognized 16 times 3 to get 4 root 3. You could have done root 4 root 12 and then had to break down root 12. Either way, you still get 4 root 3. And then root 125 breaks down to be 5 root 5. When you have variables, what you're looking for is groups of 2. Because we know a square and a square root will cancel each other out. So when we have x to the third, we are going to take out a group of 2, and we're left with 1. You do not need to write the 1. Some people like to write the 1. Reason we do this is because the square root and the square power cancel, and we get just plain old x. Here, because we have a power less than 2, that doesn't go any further. So we draw the bar across saying it stops. So we get x root x would be your final answer for simplifying. When we have root y to the fourth, we take out a group of 2. We still have another group of 2. Again, we cancel. So that cancels to be just y. That cancels to be just y. Y times y would be y squared. I'll go through one more with you. Z to the seventh. So I can make one group of 2. I still have 5 left. So I can make another group of 2. I still have 3 left. I can make another group of 2. And now I have 1 left. I'm either going to have a 2 exponent or a 1 exponent in every single term. Again, square root and square cancel, so you get z. Square and square root cancel, so you get z. Square and square root cancel, so you get z. Here I don't have enough, so that stays. I count 1, 2, 3, so that would be z to the third. And then I still am left with a root z on the inside. So that would be my final answer for simplifying. When I have multiple variables, I'm going to break down the A's, I'm going to break down the B's, and combine the final answer. So I'd like you to pause the video and try that one on your own. So again, when I do this, I'm going to go groups of 2 because they're all variables. A squared, root A squared, root A squared, root B squared, root B squared, root B squared, root B to the first. Square root and squares cancel, so I'm left with A, B, B, B. Again, A times A is A squared. B times B times B is B to the third. All of the numbers where I canceled, or all the variables, I should say, where the square roots were canceled, will go first because the radical always goes at the end. When I have numbers and variables together, I just break them down as I would. So like root 40, we would say is root 4, root 10. Root x to the fifth would be root x squared, root x squared, root x to the 1. Again, root 4 is 2. Root 10 doesn't break down, so I drew that bar saying it stopped. That goes to x, that goes to x. This one stops. Everything that I was able to cancel the square root goes on the outside. So I'm going to get 2x to the second. And then everything that's stopped, that's still inside the radical, I'm going to do, again, it's always numbers first, variables in alphabetical order. I would like you to pause the video and try the last 2 on your own. Again, so the middle one, break down 20, root 4 times root 5, k to the fourth, k squared, k squared. What I can break down, I got 2k squared on the outside, root 5. Again, the radical always goes last. The last one, again, 48, 16, and 3, so root 16, root 3. Root x to the seventh is root x squared, root x squared, root x squared, root x to the first. Root y fourth is root y squared, root y squared. Again, 4 can't, 16 became 4. All the root x squareds become x's. The root y squareds become y's. So I had 4. I had 3 x's, so x to the third. Again, these are all being multiplied. Y to the second. And again, numbers and then variables in alphabetical order, both outside the radical and inside the radical. So that's the basic part of this. When we talk about multiplying the radicals, you're going to hear me use a phrase that goes inside by inside, outside by outside. What it means is numbers that are inside the radical multiply by other values that are inside the radical. If a value is outside of the radical, it multiplies by another outside value. So on this first example, I have root 6 times root 6. Both of the 6's are inside, so I actually will multiply those together. I get root 36, which is 6. So this just equals 6. When I have 20 root 15, again, I'm going to multiply these two numbers together. I get root 300. That is not a perfect square, so then I will break it down. Root 100 times root 3, and I get 10 root 3. Again, there could be variables. So here, both the 3x and the 6x are inside, so they're going to get multiplied. So inside of the square root, I've got 18x squared. And again, I have to ask, does this break down? Well, if I ever have a variable with a power other than 1, yes, that breaks down. What perfect square goes into 18? 9 times 2. And then I've got root x squared. And again, that canceled to be x. Root 9 becomes 3. 2 doesn't break down, so we get 3x root 2. I'm going to leave the bottom one here for you to try on your own in a minute. I want to go through another example here. So let's look at this G problem. 2 and 4G are both on the outside, so we multiply. Those get multiplied first. Then we draw the radical and we multiply what's on the inside. So 5G times G would be 5G squared. Again, you always have to look at what's on the inside. Does this break down? If the answer is yes, that means you need to keep going. Root 5, well, that doesn't break down, but root G squared does. Again, anytime you have a variable with an exponent other than 1, you need to break it down further. Now, the part that people struggle with, this G here, right here, is now an outside G, which means it's going to multiply by this outside G right there. So 8G times G will be 8G squared. Again, all outside values get multiplied, whether they start outside or they become an outside number because of breaking down a radical. What is left on the inside is root 5. All right. I would like you to pause the video and try the remaining 4 problems on your own. All right, so this top right one here, again, so you multiplied it, you get 3 on the outside, root 7x squared y to the third on the inside. Root 7 doesn't break down, but root x squared does, root y cubed does. We break it down, you get 3xy on the outside, root 7y on the inside. On the next row, root 10x times root 2x becomes root 20x squared. Root 20 is 4 and 5. Root x squared breaks down. We get 2x root 5. On the next one, you multiply the negative 4 and the negative 8 to get positive 32 on the outside. On the inside, 48 times 2 is 96. X to the third times x is x to the fourth. We break down 96. I chose 16 and 6. So 16 becomes 4, root 6 doesn't, x to the fourth, x squared, x squared. Now, again, this 32 and that 4 multiply together, that's where the 128 is coming from. You could, and some people will do this, bring down that 32 in the front and go 32 times, and keep bringing it down until they get to their final answer. That is fine if you want to do that. So you get 128x squared root 6. The last one, I didn't have enough room, so I pulled the problem down here. So again, root 12 is 4 and 3. A to the fourth, again, a squared, b to the third, b squared, b to the 1. Again, you do not have to write the 1. I find it useful because then I can add my exponents to go, 2 plus 1 is 3 in the original problem. Like with C, we got squared, 1. That's where our 5 got broken into. And again, these two numbers out front, this 2 times 2 here, those two numbers, that's what multiplied to give you the 4. So your final answer would be 4a squared b c squared root 3bc. So again, I'm going through all the outsides, which are pretty much in this row right here. Those are my outside numbers. And then where were the values that I was unable to cancel out the radical? Those are still left inside. Again, numbers and then variables in alphabetical order. All right, The last thing we're going to talk about is the quotient property. Again, quotient is another way of saying divide or fraction. So this is when we have the square root of a over b. And if you think about it, we had the quotient property of exponents, which said if we had a fraction raised to a power, we applied the power to all parts within. Same thing here. If you have a radical, you can apply that to all parts. If I had AC in the numerator, I could go root A, root C over root B. So I can apply the power to all parts. So if we look something like this, we have root 13 over 100. Well, we're going to break this to be root 13 over root 100. Can I do anything with the square root of 13? No, but the square root of 100 is 10. And so when we have perfect squares in our denominator, and sometimes they're in our numerator too, but when we have our perfect squares in our denominator, we can break those down quite easily. So pause the video and try these last two on your own. All right, so root 7 over root x squared. Root 7, nothing we can do with it, so it stays root 7. Root x squared, we know, cancels to be just x. So we get our final answer of root 7 over x. And our last one, again, we apply the power to all, or sorry, not the power, the radical to all parts. So root 121, root 16, root m squared. Apply it to all parts separately. Square root of 121 is 11, square root of 16 is 4, square root of m squared is m. So we get 11 over 4m. The only thing you also have to check is, remember, these are quotients, so they are fractions. You have to double check, does your fraction reduce? 11 over 4 does not, so that would be your final answer. If you do not understand this, make sure you come to class ready to ask questions. Otherwise, have a great day, everyone.